According to specifications, the PPS is superior compared to the PPA filament, which I mentioned several times that that's the strongest filament type I tested so far. Do we have a new champion here? Let's find out. Welcome back to another material testing video, but this time completely new type for me and for this channel. This is Polymaker's PPS-CF10. Polyphenylene sulfide reinforced with carbon fibers 10%. By the way, in the meantime, the Polymaker is sponsoring not only this video but the whole channel, but my measuring results and this video content is completely independent from this. Let's see a few specifications from the website. Heat deflection temperature over 250 degrees Celsius, chemical resistant filament, high mechanical strength, naturally flame retardant, insensitive to moisture. Looking at the specifications, it is better than PPA-CF, which I recently tested on this channel, several brands. Now the print temperatures. Nozzle between 310 and 350 degrees Celsius, so quite high temperatures we need here. Bed between 80 and 90 degrees Celsius, and no heated chamber required. Very resistant nozzle, of course, because of those carbon fibers. And PPS-CF10 can be used even without annealing according to the website. So as I mentioned, I have zero experience with this type of the material, and I'm very curious about its mechanical properties, especially compared to the PPA-CF, which is actually the strongest filament type I tested so far. But looking at these specifications, this is even superior. Only it needs higher print temperatures. This packaging is really good against the moisture, but theoretically this material is less sensitive to this. And this is half kilogram spool, and now I can see very interesting information. Printing speed up to 300 millimeters per second. And the bag is resealable, only on the smaller side. End of the filament is glued. Quite brittle filament. In the meantime, I made this tool. With this I can measure more accurately this bending. Yes, it has some curve and start angle, but let's try to measure when will it break. Approximately 75 degrees. You can download this from the printables if you want to check your filament. We have only half kilogram of filament and the weight of the spool is 175 grams. And this printing speed of 300 mm per second is really suspicious. I hope it will not break inside the Teflon tube. I can feel that it grabbed the filament. I'm inserting on 300 degrees Celsius. To decide what temperature to use, I'm printing quick layer adhesion tests on 3 different temperatures, printed by objects with 2 walls and 0% infill. Here you can see the current settings, and I'm not even sure that I need 60 degrees Celsius chamber temperature, but this was preset for the kiddie PPS, which was in the slicer. I think 50 should be enough. And now it's moving to the second object, which will be printed on 330 degrees Celsius. And the last object on 350 degrees Celsius. Bed adhesion check. Oh, it's very good. Until it's hot, I will wait until it cools down. They are marked, and now let's remove them. Okay. Objects printed on 310 degrees Celsius. Don't forget these are printed with 2 watts and 0 infill. 330. Noticeably stronger. And on 350. Slightly stronger than the previous one. Definitely you don't want to print this on 300 degrees Celsius, which is the max for many printers. As I mentioned, these are printed with 2 walls and 0 infill. And I decided to print everything on 340 degrees Celsius. Here you can see my settings. The flow will be only 6. And this is the part cooling. I'm reducing it to 20 maximum. The printing looks completely nice so far. And I really like this view to the nozzle on Kiddie Plus 4. In 4 minutes the printing will be finished. Last few vertically printed test objects. The printing is finished and the bed partly cooled down. Great. Oh. Metallic sound. Oops. It will be a bell, and I'm curious how will it sound. Quick shrinking check, and I will try to measure above the elephant foot, and this is slightly bigger, so no shrinking, but this is quite acceptable. The tensile test with horizontally printed objects, and I have no idea what to expect here. This is first time I am testing this material. I tested stronger materials. Layer adhesion test with vertically printed test objects. For better comparison, I will include the data for average PPA and average ABS materials. And we can see the PPS is somewhere between, but closer to the ABS. With the layer adhesion test, this is somewhere between, but actually this is very good layer adhesion. Shear test with horizontal and vertically printed test objects, and I'm starting with these ones because the load is smaller. And now printed in horizontal position, and I don't know what to expect here. With PPS, this equipment is not enough because the maximum here is 200 kilograms approximately. Let's try. On the edge. Printed in horizontal position, it is quite strong, but it is between these two materials. Printed vertically, it is very close to the PPA because of that good layer adhesion. The torque or twist test with horizontally and vertically printed test objects, and I'm starting with horizontal one. One point five the peak. Printed in vertical position. 1.7. And again similar brake loads, but this one printed vertically breaks more suddenly. For me the load at 90-degree rotation is more important, and here it is between these two materials but closer to the ABS. Printed in vertical position, it is somewhere between these two, closer to the average value. 3-point bending test, distance between supports is 50 mm, and these loads will be placed one by one, and I'm measuring the deformation after 1, 30 and 60 seconds. This is a deformation under 1.25 kilograms, under 2.5, under 5 kilograms, and pay attention, almost no additional deformation during the time, even under 10 kilograms. Compared to the PPA, it has slightly more initial deformation, but compared to the ABS, look at this, how big deformation is on the ABS, and here we don't have additional deformation even under 10 kilograms. Impact test with this half kilogram hammer. 0 position. From the 0 position, 23 mm is the edge position of the hammer, and from this I'm calculating the braking energy, and this means that PPS is quite brittle material compared to the PPA, but of course compared to the ABS, and unfortunately this is very typical for the fiber reinforced filaments. The creep test of deformation under constant load of 1.25 kilograms. 12.79. For the first look, the deformation looks very similar to PPA. I already did the test with this one, just side by side shortly to show you. As you can see, very similar deformation. And the last fifth day, 12.84. This deformation is slightly bigger compared to the average PPA, but far less than average ABS. But the creeping that changed during the time is almost zero, exactly like with the PPA materials. The temperature test in the oven. Even from the specifications, I knew that I will reach the maximal temperature of my equipment, and probably I will not record any deformation on this PPS material. Stop the experiment at 230 degrees Celsius. Actually, there's a micro deformation on this test object, but not big enough to record the temperature when it started. Our results one more time without any additional comments. And this one line will be added to the summary table for my pattern supporters, and basically this is my only gift for them. And soon I will test 2 more PPS filaments, so we will have a better comparison and more information about this material. I'm not sure why I thought that PPS will have better mechanical properties compared to the PPA. Maybe because of this table generated by AI, or maybe because of the higher print temperatures. Of course, it still has its own advantages, better chemical temperature resistancy and similar. And actually I want to investigate this a little bit deeper. So in a separate video, I want to compare PET-CF, PPA-CF and PPS-CF from the brand which have all three in their offer. And big thanks to the Polymaker, who became a channel sponsor in the meantime, and they are supporting all my research work, even if I am testing other brands too. And of course, big thanks to all my Patreon supporters, because thanks to them I decided not to have ads during the video, because I'm much happier with the Patreon donations and I don't need those extra 25% which is offered me by the YouTube studio. And if you like this kind of videos, don't forget to subscribe and enable that notification bell button too, because in most cases my videos are not really recommended to regular subscribers, only to those who enable those notifications. Well, thank you for watching this video and I wish you happy printing.